Hello. This week in chemistry, we are going to work on writing chemical formulas and naming those compounds. So by the end of the week, that's what we're hoping that you're able to do. And here's some nice pictures of ionic compounds. This is what they look like. And like I said, that's what we're going to be trying to do this week, is to be able to write the formulas and name them. All right, so just a couple reminders as we've been talking the last couple of weeks, because this is really what we've been building up to. Remember that if we look at the elements that are in the same group, that means the same column on the periodic table, they're going to have similar chemical properties. The reason is because they have the same number of electrons in their highest energy level. We often call that the valence energy level or the valence shell. Now, chemical bonds form when the elements do things with those valence electrons to form a stable arrangement together. And the kind of bonds that we're looking at this week, ionic bonds, and when they form these compounds, the atom gets a full valence shell, just like the closest noble gas. And they can do this by either losing an electron or gaining an electron, or multiple electrons. You'll remember from last week that metals lose electrons to form positive ions. So this means you remember that when we have an atom, it has an equal number of protons and electrons. So it has a zero or neutral charge. But if a metal loses one electron, it would become a +1 charge. If it loses 2 electrons, it becomes a +2 charge. As nonmetals are the opposite, of course, the nonmetals way over on the right side of the periodic table, they generally gain electrons to form negative ions. So when an atom gains 1 or more electrons, it would become a negative ion. So specifically, if it gains 1 electron, it's got a -1 charge. If it gains 2 electrons, it gets a -2 charge. And so how do we do this? Well, one of the ways that we can do this is if we have a compound like sodium chloride, and you all have this. Sodium chloride is what you put on your French fries, right? Sodium is a metal. If you look at your periodic table, it's way over on the left. Chlorine is a nonmetal. Right? And so we simply write the symbols for the two elements. Sodium's symbol is Na. I know that's one that always throws us because it's not SO. And chlorine is Cl. And then what we would do is we would figure out if it's a metal or a nonmetal. Obviously, we've already figured out that sodium is a metal. Chlorine is a nonmetal. And then we would write out those chemical symbols, just like we've done here. So here's the steps we've already done. We know chlorine is our nonmetal, sodium is our metal. We've already written their symbols. Now here's where you may want to use the periodic table that is in this week's folder and figure out the charges. So sodium +1, chlorine -1. And so if you're in math class and you're doing this math problem, +1 and -1, you would get 0. And that's exactly what we must get for all of our ionic compounds. The other thing that you can do is you can cross the charges. So the 1 by sodium becomes 1 by chlorine. The 1 by chlorine becomes 1 by sodium. Drop the charges, remove those charges, and that would be your formula. But obviously you don't need to have the 1s in there. And so there's your formula, NaCl. Let's take a look at another one. Here we go, calcium oxide. So in calcium oxide, we're talking about the metal and the nonmetal. So look at your periodic table. Calcium is your metal. Oh, you probably can't see that because it's a little bit off the screen there. There we go. Let me get it up there for you. Oxygen is your nonmetal. Now let's figure out the symbols for calcium and oxygen, because that's our next step. So the symbol for calcium is Ca. The symbol for oxygen or oxide is O. So we would write those. Now we've got to look at the charges. So this is where you may want to look at that periodic table that you have in this week's folder. Figure out what is the charge for calcium, what is the charge for oxygen. If you thought +2 is the charge for calcium, you're right. And -2 is the charge for oxygen. Oh, look at that. So do the math. +2 -2, what does that equal? If you said 0, you're exactly right. And so that is your formula just as written. The other thing you can do, of course, is to use that cross rule. So cross the charges. So the 2 by calcium goes down by oxygen. The 2 by oxygen goes down by calcium. Get rid of the charges. So you have to remove the charges. And so let me move this screen down a little bit so you'll be able to continue to see. Get rid of those charges. Simplify the numbers. So obviously 2 and 2, you could simplify that to be 1 and 1, or basically you just have CaO, like we already said. So there's how you write the formula for calcium oxide. Let's take a look.